Welcome back. Today we're going to talk about interpreting confidence level and what it means to have a confidence level for a given estimating of a certain parameter. We're going to divide this box into three parts. The first part is going to be a little bit bigger than the other two. And the first concept that we're going to talk about is interpreting confidence level. Now, this is one of those prompts, kind of a fill-in-the-blank sort of a deal, and we're going to use this in different contexts when we talk about confidence level in general. This is what it looks like. If we take many samples and calculate a confidence interval for each about blank percent of them will contain or capture. Let's use the word capture. That's a better word, capture. The true, and this is where we fill in the blank again with either our proportion or our mean, and then we put it in context. So what does that mean? It would be like this. We set up a 95% confidence interval, or we're 95% confident that a certain interval captures the true mean. And this is what it is. So it would involve us taking many samples, about a certain percent of them, which is our confidence level, captures the true mean within that context. Okay. Second thing is the margin of error. So the margin of error fluctuates. So when we look at margin of error, let me pull this up right here. Here we go. So here's a little applet. I'm going to reload it. Our margin of error has to do with creating the interval. So here's what I've got. I've got a population proportion of 0.5 with a confidence level of 95%, and then our sample size of 20. And I'm just going to pull up a set of samples here. And now what you'll notice is you've got this green line in the middle, which is our true proportion, so 0.5, true proportion of our population. And then each of these intervals here has a dot in the middle, which is our point estimate. And then it has these lines that come out from it, which represent our margin of error. So the margin of error on either side. Well, what I can do is I can manipulate these variables, right? So I can manipulate the confidence level, and you're going to see exactly what it does for our different intervals. So let's just say I take my confidence level and I move it down to 80%. And you're going to notice right away that I have smaller margins of error, right? I have smaller intervals. For effect, let me turn it back up to 99. See how wide they are? And I turn them down to 80 and they get smaller. Well, if you think about it, if I've got a really wide interval and I say, oh, it's between these two values that are really far apart, that's going to make me more confident, right? So anywhere from 0 to the percent of rain is between 0 and 100. Well, of course it's between 0 and 100. It might rain or it might not. Well, it's going to be a really wide interval. But if I say that the interval is from 30 to 60, that's going to be a narrower interval. And so what does this have to do with what we've been talking about? Well, our margin of error, if our confidence level goes up, then our margin of error increases. So our confidence level goes up, our margin of error increases, meaning those arms on those intervals get longer. The other piece that we're looking at here is, what if we put our confidence level at 95? What if I change my sample size? So let me jump up the sample size. Jump up the sample size here to 100, and I'm going to sample 25. Check out how narrow these margins are. So these margins of error are very narrow. And speaking of kind of like this whole relationship, if you'll notice, I have all margins, or I have all confidence intervals that are black because they all overlap that green and they all capture the true mean. If I sample another 25, I have I have all of them that meet. Well, in the middle of this one, I finally have a red one. So I've taken 75 samples and 74 of them are hit. So right now, in many, many samples, I have 98%. But as I continue to hit sample 25, you see how my margin or my percent hit is going down. Well, as I would increase that, the total number of the total number of intervals drawn, I'm going to get closer and closer to 95%. Well, changing my sample size and increasing my N causes my margin of error to shrink. My margin of error goes down. Well, if you think about it logically, if I ask two people and one of them says yes, one of them says no, all of a sudden I have 50%. Then I ask a third person. Two say no, one says yes. As I ask more and more people, I'm going to get a better idea, a more precise idea of where my actual answer lies. And so what we would say is, when our confidence level goes up and our margin of error goes up, we have a wider interval. When my sample size goes up and my margin of error goes down, we have a narrower interval. A little bit more about margin of error. The margin of error does account for sampling variability. But it does not account for these three things. 1, non-response. 2, undercoverage. And we're going to talk about that in just a minute. Or 3, response bias. Okay, so margin of error does account for variability in sampling, but it does not account for non-response, undercoverage, or response bias. Let's do an example here. The gym teacher of a large high school wants to estimate the mean number of push-ups students at his school can do in 1 minute. The whole school. He selects a random sample of 30 students from those who are there after school for sports practices. He records how many push-ups each of the students in the sample can do in 1 minute. He determines that he is 90% confident that the interval from 24.1 to 28.5 captures the mean number of push-ups that student at the school can do in 1 minute. So let's interpret our confidence level here. Well, if he's 90% confident, and by the way, a good way to do this check understanding would be to pause here and come back after I've done it. So you pause here and you try it, and then you can come back and see my commentary on it. But if not, then I'm just going to keep rolling through. So interpreting the confidence level. What this means is if the gym teacher takes many samples and calculates the confidence interval for each. About 90% of them will capture the true mean number of push-ups. And here's our context, that students at the school can do. Okay, so explain what would happen to the length of the interval if the confidence level were increased. So when the confidence level increases, meaning I'm more confident that this interval contains the true mean, then it is going to get wider. And our margin of error increases. How would a 90% confidence interval based on a sample size of 200 compared to the original 90% interval where it was n equals 30? Well, if you have more people, increasing the sample size is going to cause that to shrink, so it's going to be narrower. Okay? Describe one potential source of bias in the study that is not accounted for by the margin of error. Well, let's think about this for a second. How did he sample here? He took people who are in the after-school athletics program. So we could say this is undercoverage because students who are not after school athletes did not have a chance to be part of the sample. Okay, so students who aren't a part of athletics didn't get a chance to be a part of the sample. So that is called undercoverage. All right, guys, that is the basics of how to interpret confidence level. I